What's up everybody and welcome to a new video. And in this video, we're gonna start to go over my notes for data structures in Python. So what is a data structure? To me, a data structure is simply a collection of elements. And those elements here can, for example, be data types. So the data types that we've discussed in the previous videos. Then they can be other data structures. So this would then be called nesting. And we talk about nesting when we talk about here the miscellaneous topics. And then here we have nesting. And those elements can also be functions and classes. And those we will also talk about in more detail later in this series. So this is how I define data structures, and available data structures in Python are lists, tuples, dictionaries, and sets. So now in this video, let's go over my notes for lists in Python. And here I also have a definition, namely I define them as a collection of items in a particular order, i.e. when working with many values, instead of creating a variable for each individual value, what you can do instead is to put them all into a single list. So for example, instead of doing something like this here, where you have different variables, so here customer 1, which is Tom, customer 2, which is Gary, customer 3, which is Joe, you can all put those customers here simply into a list, and therefore then also into just one variable. So for example, if we say here customers, and then to create a list, you simply use those brackets here. And then here you can then list all the items, all those customers here in this case, by separating them with a comma. So for example, if I then say here Tom, comma, Gary, and then lastly Joe. And now if I run this, then we've created here this list with those 3 customers here. So this is how you create a list. And here I also have some side notes. The first one is that the elements or items of the list don't have to be of the same type. So for example, here we have only used strings, but as I said here, those elements don't have to be of the same type. So for example, if we create here then an arbitrary list, and then again here use the brackets. So here now let's use different types. So for example, we can here put in an integer, then a string. Then, for example, we could also put in here a Boolean value. And then lastly, here we could also, for example, put in the none value. And now if I run this cell, then you can see that we don't get here an error. So you can put different types into a list. So then this last side note here is that list can also be empty. So for example, if we then here create an empty list, therefore you simply then use those brackets without putting anything in them. And here again, if I run the cell, that you see then you can see that we don't get here an error. So those are the side notes. And with that, now we've covered how I define lists and how they are denoted. Then the next note is about list methods. And here I've created those different categories here. So the first category is called add elements. And here, the first method I want to talk about is the append method. So with that, you can simply append elements to an existing list. So for example, here I've prepared a list. So let me copy and paste that. So here we have a list with 1, 2, and 3. And now let's say that we want to append a 4 to this list. So therefore then we would simply say list.append and then 4. And now if I run this and then print out here our list, then you can see that this 4 now was added to our list here. So that's append. Next we have extend, and with that you can append multiple elements at once. So for example, let's say that here in our list example here, we don't just want to append a 4, but we want to append a 4, 5, and 6. So then instead of running this function here 3 times with append 4, append 5, and append 6, we can simply use extend. So what you can do is to say here list extend, and then here put in an iterable. So for example, another list, and then here we put all the elements that we want to extend our list with. So for example, then 4, 5, and 6. Now if I run this and then print out the list here, then we can see that we have here 1, 2, 3, 4, 5, and 6. And here now, just as a side note, if you would use here append in this case, then what would happen is that this whole list here would be appended as just one element of this list here. Okay, so that's extend. And then lastly, we have here insert. So with that, you can, as the name suggests, you can simply insert a value into your list. So therefore, let's here again recreate this list. And now let's say that we want to insert a 99 between this 1 and this 2 here. So therefore, then we would say list.insert. And then first you have to specify the index. So in our case, that would be 1. So our value should be here at this place. And then you specify the value that you want to insert. So for example, then we would say 99. And then here, if I print out the list, then now you can see that this 99 is now between the 1 and the 2. So those are the methods that are available to add elements to a list. So then the next group of methods is for removing elements. And here the first method is simply called remove. And with that you can remove a specific value from a list. So for example, therefore I've prepared here this list, which has 1, 2, 3, and then 1. And now let's say that we want to remove here this 1. So therefore then we would say list.remove and then 1. And then here, as you can see, if we print out the list, then you can see here this first one was deleted. So now let's also delete this second one here. So therefore then we say again list remove the 1. And then here if we print it out again, then you can see that also the second one was deleted. And now let's see what happens if we try to remove a value that is not in our list. So therefore again, let's say list.remove 1. And then here if I run this, you can see that we get a value error because X is not in the list. So this 1 here is not in this list. Okay, so that is remove. Next then we have pop, and this has a default behavior. Namely, by default, it pops the last element in a list. So for example, therefore let's use again here this 1, 2, 3 list. And then here, let's say list.pop. Without specifying a value, and in this case then you can see that it returns here the 3. So this 3 here was popped. So therefore then if we print out the list, we can see that it only contains 1 and 2. So now let's pop again. Then we get here the 2, and now only this 1 here is left. So now let's run pop again to also pop this 1, and now we can see that we have here an empty list. And now let's see what happens if we try to pop from an empty list. So again, let's say list.pop, and in this case then you can see we get an index error because we try to pop from an empty list. So this is the default behavior, but you can also specify an index. So whereas with remove you specified the value that you wanted to remove, here you can also specify, with pop, you specify the index of the value that you want to remove. So for example, let's go back up here again and recreate this list. And now let's say that we want to remove this 2 here, which is at index 1. So therefore here we specify the index 1. And then you can see here it returns 2. And if we look at our list, you can see it contains 1 and 3. So now if I pop again here with index 1, then it returns the 3. And then if you look at the list, it only contains 1. And now let's see what happens when we now try to pop from index 1, which is not available here in our list. So in that case, then here we get an index error because the index is out of range. So that is pop. And here I also have a side note, namely a similar functionality is available via the delete keyword. However, there are some differences. The first one is that no value is returned. So for example, therefore let's use again here this 1, 2, 3 list and then delete all those cells. So now let's say again that we want to delete this 2 here. Therefore we could use this delete keyword. So we would say delete and then list and then specify the index of the value that we want to delete. So again here the 1. And then here if I run this, you can see it doesn't return anything. However, if you look at the list, you can see that the 2 was deleted. So that's the first difference. And the second one is that you can also delete slices with this there keyword. So for example, if we create here again this list and then here create a slice with 1 colon. So this means then that we want to delete everything from the value of at index 1 until the end. So we want to delete this 2 and this 3 here. So then if I run this and then print out the list, then you can see that 2 and the 3 were deleted. So this is the side note. And with that, we have cover pop. And then lastly, here we have clear. So with that, you can simply clear a list. So you can remove all the elements in a list so that it's then empty. So for example, if we then say list.clear, and then if I run this and then print out the list, then you can see that we have now here an empty list. So now let's just quickly see what happens when we try to clear an empty list. So let's here run list.clear again. And then, as you can see, we don't get an error and the list is still just empty. Okay, so those are all the available methods for removing elements from a list. Then the next group of methods is about finding elements. And here, the first method is called count. So with that, you can simply count how often a specific value appears in a given list. So for example, therefore, I've prepared this list here. So this contains ABC and then AB. And now let's say that we want to count how often this value A here appears. So therefore, then we simply say list.count and then A. And if I run this, then we get here 2 because there are 2 A's here in this list. And now let's also see what happens if we try to count something that is not in the list. So for example, the letter Z. So therefore, then let's say list.count Z. And then here, as you can see, we get a 0 because there is no Z in our list. So that's count. Next, we have index, and this simply returns the index of the given value. So for example, if we say here list.index of A, then we get here a 0 because the A that it first finds is this one, which is at index 0. However, here you can also use some optional parameters. Namely, you can specify a start and a stop value. So for example, if I say here start at 1, so we actually only start here at this position. Then if I run this, then you can see we get here a 3 because then the first A that it finds is this one, which is at index 3. And then you can also specify a stop value. So for example, if I say here a 3, then we get here a value error because A is not in the list, and that's because this 3 here is not included. So we are only looking at those 2 elements here. Okay, so then lastly, let's also see what happens if we try to find the index of a value that is not in the list. So in this case here for the Z. And then here again, we also get a value error because Z is not in the list. So those are the available methods for finding elements in a list. Then the next category is about changing the order of the given list. And here, the first method is called reverse. So with that, you can simply reverse a list. So for example, therefore, let's use again here our 1, 2, 3 list. And then here, if I say list.reverse, and then if I print this out, then you can see that our list here was reversed. So that's reverse. Next, we have sort. And with that, you can simply sort a list. So for example, here I have this 2, 3, 1 list. And now let's say we want to sort it. So we simply say list.sort. And then if I print it out, then you can see that it was sorted in ascending order. And if you want to do it the other way around, so in descending order, then you can use here this reverse parameter and set that to true. And then you can see that our list now is sorted in descending order. So we have then 3, 2, and 1. And sort doesn't just work for numbers, it also works for strings. So therefore, I've prepared this list here. So we have BCA, and now if I say list.sort, then we get here our list sorted, which is now A, B, and C. And here I also have a side note, namely, this is about dealing with uppercase letters. Namely, here I have a list with an uppercase letter. So here again, we have BCA. However, C in this time is now a capital letter. So now let's see what happens if we run sort on this list. So here, if I now print this out, then you can see that C is actually here at the first place in our sorted list. And that's because uppercase letters have lower ordinal values than lowercase letters. So for example, if I say here ord and then capital C, then we get here a 67. And now if you look at the ordinal value of A, for example, then we get here a 97. So that's why the C here is listed before the A. And one way you can deal with that is by using here this key parameter. So here you can provide a key function, and then what that does is that this list then will be sorted based on the return value of that key function. So for example, if we say here string.lower, so this function will simply transform our values here into lowercase, and then those values will be based on the return value of this function. So now if I run this with this key function here, then you can see that now our list is sorted correctly. So we have A, B, C, and you can also see that the C here is still an uppercase letter. So this key function here doesn't affect the original values. It's just used for sorting those values. Okay, so that's the side note. And with that, now we've covered all the available methods that are available for changing the order of lists. And then the last category is called mutability. And here we only have the method copy. And I've created this category because the copy method is going to be very important when dealing with mutability. And we talk about mutability when we talk about the miscellaneous topics here. And here is mutability. So if you don't know what it is, then I will put the link to that video into the video description. But now I just want to quickly show what this copy method here does. And therefore I've prepared this code example here. So here we have three variables, A, B, C. So A is simply set to a list which contains 1, 2, 3. B is set equal to A, and then C is set equal to A.copy. So now to see what this copy method does, let's print out all the IDs of those variables here. So here we're going to say print ID of A, and then we're going to do the same thing for B and C. And now if I run this, then you can see that A and B have the same ID, whereas C has a different ID. So what's happening here is that when we say A is equal to this list, then this list here is created and stored in a specific location in memory. And then here, when we say B is equal to A, then here what happens is that B is simply pointing at whatever A is pointing at. So in this case, this list here. So that's why then we get here the two same IDs. And if we say, when we then say here C is equal to the copy of A, then what happens is a copy is created of this list, and this copy is then stored in a different location in memory. So that's why we get then here a different ID. So this is how the copy method works. So with that, now we've covered all the available list methods, and with that we've covered all my notes for lists in Python. So we've reached the end of this video, and then in the next video we're going to go over my notes for tablets in Python. So thanks for watching, and hopefully I will see you in the next video.